welcome to another episode here on the Total Space Network. Today we have a very special episode. It's an interview, and with me interviewing today, would you like to introduce yourself, Mikko?
Yeah, I'm Mikko, the host of Deep Dive, and our special guest today is Tim Alatorre, co-founder and COO of Orbital Assembly Corporation. Welcome.
Thank you so much. Glad to be here.
So, Tim, would you like to tell us a little bit about yourself to get started, what your day-to-day looks like at OAC right now?
Sure. Yeah, so as Mikko said, I'm a co-founder and chief operating officer. We're still a relatively small company, so I do wear a bunch of other hats as well. It's all hands on deck. But the day-to-day at Orbital Assembly Corporation right now, I'm not sure how familiar your audience is with what we've been up to, but we are designing and building space habitats for people to live, work, and thrive on orbit for long periods of time. And one of the key things that we've discovered over the last 20 years of having humans living permanently in space on International Space Station is that microgravity is really rough on the human body. And so what distinguishes us from some of the other space station companies that are out there is we are actually providing gravity. We're building structures that are going to be rotating and creating artificial gravity to where we can start to mitigate and offset those detrimental effects of microgravity. So day to day right now is we are really pushing hard for our 2023 launch of our gravity ring project. And that will be the first on-orbit demonstration of circular truss construction at scale. And we're going to spin that up and create artificial gravity. And so, it's the engineering, the design, the financing, getting the partners and customers lined up. There's just a whole lot of work. 2023 is basically tomorrow. And so we're really pushing. It's a sprint to get that first mission up there.
That's actually run straight into our first question of when will we see an orbital demonstration of the on-orbit building technology. So that gravity ring you're looking to, is it get into orbit by 2023, or is it actually beginning the process of 2023?
So our roadmap right now is to have the first launch, which would be our P-Star, our Pioneer class structural truss assembly robot. And then the structural components for Gravity Ring would launch in 2023. And then the P-Star will assemble Gravity Ring on orbit. It'll take all those truss components, put them into a big circular truss. And that is in our roadmap to be done in 2023. Now, there's a lot of other pieces and parts to that. Like right now, we're finalizing our launch contracts with our launch providers and, launch schedule availability and windows for launches. That may shift that time frame a little bit, but we're going to be ready in 2023 for that launch.
Awesome. That's actually great to hear. So the next question then is, you've answered a little bit already in terms of what you're doing with Gravity Ring in terms of getting those little milestones now. Are there any other projects that Orbital Assembly Corporation are working on right now alongside that to help make that happen?
Yeah, absolutely. That's a great question, Rich, because everything that we do is designed to feed forward into the next project. So earlier this year, we had a ground demonstration of our demonstrator structural truss assembly robot, the D-Star, and we had a public demo of that in Southern California. And the design and engineering for that is feeding right into the design and engineering for the P-Star program, which will build Gravity Ring. And that program will feed into the next program, which is our Pioneer class station. You pick up Pioneer, the P-Star, the Pioneer Station, or structural truss assembly robot. So the Pioneer Station will be a first habitable station, smaller in scale than our next gen stations, and that will follow right on the heels of Gravity Ring. So we're working concurrently right now on Gravity Ring and Pioneer Station because that technology all feeds into each other. And then Pioneer Station feeds forward into our next generation of station, which is much larger, which will be the Voyager class space station. And so we're also doing design on that because we want to make sure everything we're doing now doesn't become obsolete. It feeds forward and can be adapted or reused or repurposed in some way. It's launch costs are coming down, but it's still very expensive to get mass into orbit. So we want to make sure that anything we're sending up there has a long life and that we can use it for a long period of time.
Yeah, that's a great philosophy to do something that will enable you in future. But yeah, I'm interested in why was Orbital Assembly Corporation founded and what inspired you?
Yeah, I think the origins of Orbital Assembly Corporation really come out of a bunch of space nerds who have been, dreaming and thinking of space for years. And in many cases, a number of the co-founders actually have been working in space and designing and launching spacecraft. We're saying, well, why don't we have large numbers of people living in space, right? If you look back to the 1960s with the Apollo program and the space race to the moon, it was just kind of in public perception that the next step would be moon bases and solar, space stations in LEO and solar power stations in orbit. All these things that were in the public consciousness at that time, and they really just didn't happen, right? We've got a lot of really good sci-fi over the last 40 years or so, but not a lot of real science. And so we said, well, why hasn't it happened? There's a couple of things. One, launch costs have been pretty stagnant for a long period of time. And we were looking at what SpaceX was doing and realized launch costs are going to start to come down. And they have quite a bit. Launch prices to get a kilogram of mass into orbit pretty much since the 1960s have been around $10,000 a kilogram. SpaceX now is getting that down to the $3,000, $4,000 a kilogram range. With Starship coming up, we see that going in an order of magnitude even less expensive. So cost, launch cost was the first barrier to entry. Second one was the technology. Do we have the engineering and technology know-how to build large things in space and to sustain life in space? And the answer to that was resoundingly yes. 20 years of ISS, not to mention all the programs and things that happened before that, we have the technology. We know how to do it. So then the only other real barrier to entry was who's going to pull all this together and get the financing and the team to make it happen, right? And so we were looking at who was in the market at that point in time. And I think it's kind of like the same thought process Elon Musk went through when he started SpaceX, right? He was first saying, hey, I want to inspire other people to get to Mars. And then he realized, well, no one's going to do it. I guess I'll just do it. And that was the realization we had, right? No one else is stepping up to do this. Let's just do it. And so that's been the mission, since those early conversations. And then we finally incorporated in 2019 is putting together the team, the financing, all the partners to make this a reality. And, since we put this vision out there, we have just been supported so much by the space community, by other private space companies, by the public at large. And so all of those pieces are coming together, and we're going to make this a reality.
Yeah, that's awesome. And while you were speaking about the launch prices, how about the prices to get up into your station? How much would that cost? Will it be, well, let's say in my reach within the next 20, 30 years, or just the normal people, could they get into space on your gravity station or something like that?
Well, I hope that the average person can get to our station a lot sooner than 20 or 30 years. Staying on our stations, it's basically like going to a hotel or, some resort or some terrestrial destination. There's a certain amount of capital expense that's required to build the facility, and then you amortize the cost of that over a period of years, and you figure out your ticket price, right? The real cost variable that is in flux is those launch costs, right? So with the cost right now of Falcon 9 and Dragon capsule, a ticket to get to LEO is pretty much set by SpaceX, and you're looking at millions of dollars. But as we get to next generation space vehicles like the Starship or the New Glenn by Blue Origin, we're going to see those launch costs come down. So if you think about, you want to go to, let's say, Europe for a vacation, we're going to have different options, just like you might if you're going on vacation overseas, right? You're going to have your hotel costs, your food costs, and you'll have a range of prices. So let's just throw out a number of $300 a night or, 300 euros a night for a hotel. that's not going to be your biggest expense. It's going to be your airfare or your transportation to get over there. So we haven't dialed in our costs on what a night stay is going to be at on the station, primarily because that's also tied to our launch costs of getting it to orbit. So as we start to get closer to those launch dates and we start to hone in and get those launch contracts in place, then we'll be able to really give a clear idea of what that is. Right now, it's millions of dollars just because that's where launch costs are. But we really see that coming down to the $1,000 range, maybe the tens of thousands of dollar range within the next decade. And at that point, that starts to become really reasonable for people to say, hey, I want to go spend a week at Disney World this year, and next year I'm going to go and spend a week in space, right? Those start to become real conversations that families can have.
Yeah, absolutely. And yeah, I would totally visit the station and spend a night or a few there. It would be great.
Well, you know what's amazing, Mikko? People have paid to go to spend the night on International Space Station, which is a really stinky, dirty laboratory. It really isn't a pleasant place to stay. You have microgravity. Your toilet is a vacuum. You're eating cold foods. It's camping. And then we had the Inspiration 4 mission that recently went up, right? And they were, those 4 crew members were in a space capsule, basically the size of a small van or a SUV, right? And it was just the 4 of them. They didn't have a whole lot to do, but they had that cupola, which allowed them to view out to Earth. And resoundingly, all 4 of them, when they came back, they said, we could have been there longer. We wanted it to be longer. 3 days wasn't enough. And, people ask, what are you going to do on your space stations? And we're going to have all sorts of recreational activities and, things for people to do. But I think a lot of people are just going to spend days just looking out the window at the Earth passing by. It's going to be really an experience that people are going to cherish and want to come back for more.
Yeah, absolutely. And you were talking about your stations that they would be using artificial gravity. What is the importance of researching artificial gravity on orbit?
Yeah, that's a really great question because I don't think a lot of people understand. We have 20 years plus experience in microgravity, and we have thousands of years experience in 1G, Earth gravity. We have a few minutes at most, few hours at most of the Apollo astronauts on the moon in our experience with lunar gravity. And so there's whole textbooks that haven't been written yet about artificial gravity scenarios. One of my other team member at Orbital Assembly, Jeff Greenblatt, he's our CVO. We were at a National Space Foundation and NASA NIAC workshop a couple weeks ago, where we were in a room with 70 other specialists in different fields, and we were working on what does the future of humanity look like for large-scale communities, like the tens of thousands, hundreds of thousands in space. And across the board, in this room of professionals, there was a resounding need for research to be done in artificial gravity. There were so many questions, and people kept saying, well, what we really need is a test bed in low Earth orbit where we can start to figure out these answers. And so that's what our 2023 mission is. We're going to put up Gravity Ring. We're going to have some scientific, for academia and commercial payloads. We're going to start doing those tests on artificial gravity. Combustion is going to work differently. Mitosis, plant growth. We don't know how human gestation is going to work in artificial gravity. There's so many things that we're going to start to get those answers.
Definitely a lot of science there. And speaking of science, actually, there's another point I wanted to bring up. Obviously, one of the ways you might be able to write off some of the cost for Gravity Ring is to be able to include areas on the ring itself where you can sell space for scientific payloads for various clients, right? Have you thought about something like that, for instance, to maximize your income from Gravity Ring?
Yeah, absolutely. So Gravity Ring is a smaller station design than Voyager Station, but Pioneer Station, which will be the next step up from that does have a central docking hub and access tubes that come out radially. And so that will offer that opportunity to have variable gravity levels while the station's at a fixed rotation rate. Gravity ring, what we're doing to combat that is there's no people on gravity ring, so that gives us a lot of flexibility to increase and decrease the rotation rate. So we do have commercial partners who are going to be hosting payloads on gravity ring. The only one I can announce right now is Leo Cloud. We put out a notice about that earlier, and they're doing a cloud computing platform on gravity ring. And now they're not as interested in the artificial gravity component. There's some interesting things about communication when you're on a rotating platform that is of interest to us and them, right? But for payloads that want variable gravity levels on gravity ring, we'll just speed it up or slow it down. And then with Pioneer Station, we can do longer term experiments at variable gravity levels because we will have those access tubes. And then, like you mentioned, the next station up from that, Voyager, we'll have lots of opportunities for large scale research, really, taking it up to the next level.
So, in terms of Voyager Station, which is your larger project, could you see yourself working with more international partners on a larger project like that, or is the plan for OAC to upscale and be able to absorb all of that burden itself?
Yeah, that's an interesting question. We've been bouncing it around internally. Right now, our timelines are so short, and we're trying to get things done so quickly that dealing with all the regulations related to bringing in international partners has been something we haven't really wanted to get into too much. So we've been trying to, do it as much, at least within the United States, legal system as possible. But there are a lot of potential partners there. Yeah, one of the things we're dealing with is things are moving so quickly right now. We have a lot of stuff in the works that I can't talk about publicly yet, but we have, press releases coming out on a regular basis now. So I'm trying to remember which press releases have gone out.
Yeah, well, speaking of press releases, we did interview Rogue Space Corporation, who will be lending you some robots for, I think, assembly or something like that. But what kind of robots are you using to build the stations?
Yeah, Rogue Space, Jeremy, founder and CEO over there, a good friend of ours. And that's an example of a collaborative partnership where they found out about what we were doing, and we saw some potential synergies there, and they've just become a really valuable partner for us. And they really fill the niche of an area where we were concerned that it might hold up our timelines, right? Building advanced robotics takes time. Not so much the hardware side of it, but the software side is really time intensive. And so Rogue Space was quite a ways ahead of us on their path to creating semi-autonomous and autonomous robotic platforms for very purpose, kind of general purpose robotics, right? And so on our 2023 mission with the Gravity Ring and P-Star, we are going to have a couple of Rogue Spaces Orbots on our launch, and they're going to be providing observational capabilities. So they're going to detach from P-Star, and they're going to, maneuver around our construction yard, providing us real-time visual and other sensory data. So it's a real great support for us. Now, Rogue Space also has some other Orbots that they're developing, which would also potentially be used in moving materials around the construction site. But for the Gravity Ring and the Pioneer Station missions, our P-Star platform is really our construction yard. That is the robot. So that P-Star device has maneuverability and station keeping capabilities. It's got orbit maintenance capabilities. It's got all the different manipulators and mechanisms to move pieces around and connect them, drive bolts, attach propulsion systems, attach electronics. It's a very purpose-built robot that does a lot of tasks in a very small package. So the P-Star is an incredibly capable machine. And then the next generation from that will be the Voyager class structural truss assembly robot. And the structural truss assembly robot is kind of a heritage name, but the robot doesn't just do trusses anymore. It really does a lot of other things. You could think of it kind of like a Swiss Army knife. It's just it's got a tool for everything.
That's definitely what you want up there in space, so that if you've got a problem that needs fixing, you're like, aha, if we use it this way, it will work.
Yeah. Jeremy is great. I've talked to him twice already. He's been on the show here.
We really value rogue space, and we were, like I said, we were developing those robotic drones in house, and we were looking at fast tracking that internally, or hiring a consultant to come in and help us. But just the time frames on that, like I said, Rogue Space was ahead of us on that. So it's just a perfect partnership.
If I may, how large is OAC currently, and are you hoping to hire more soon? Is the plan to scale up soon?
Yes, to that second question, and I just had the recent count. We are up to let's see here, we're at 20. We just hit the 20. So there's 20 people on our team, and yes, we are looking to hire primarily on the engineering side of things. There's just, when you're starting a company, there's so many business dev tasks that you have to fill, right? And so we started off really engineering heavy. We built out some of the support people, and now we're going back to refocus on engineering. So we're in the middle right now of a crowdfunding raise on the Net Capital platform. And if anybody's interested in supporting us, you can go there and actually buy stock in our company. And so the funds from that raise primarily are going to be going to allowing us to onboard additional engineers. And really, we need additional engineers to stay on our schedule. So that's the step over the next couple months.
So like many in the space industry, 2020 presented a great many challenges. As the world finds its new normal, what are you most looking forward to being able to do as a company?
In the context of coming out of the post-COVID world.
Yes.
Or I guess we say post-COVID, but it's still here, right? I think that the challenges of COVID and really global pandemics and viral pathogen transmission in general aren't going to go away anytime soon. I think they're going to be with us for a while. So we are finding ways to cope and adapt. This year, in particular, in 2021, since the summer, our team's been very active in traveling and meeting with partners. And so, as often as we can do that and get in our vendors' facilities and see their production team and talk with their engineers and find out how's this component being made, we want to do that as much as possible. But video conferencing, Zoom or whatever platform you're using has made business so much easier from a remote standpoint. So our team is really geographically diverse. We have people from coast to coast on the continental United States, and we have regular meetings, and everybody's able to do their job. And I think that gives us a lot of flexibility for hiring and bringing in people, but also allowing us to move faster at a faster pace. So I think that's one of the big benefits of COVID, is that we're all now used to doing video conferencing. People who never would have thought of it before, it's just now second nature. Now we might get tired of it. Zoom fatigue's a real thing, but it's more mainstream than it used to be.
Thanks for watching. Remember, this is part 1 of a 2-part interview. If you'd like to see part 2 earlier than everyone else, consider supporting us on Patreon for early access and much more. Remember to give this video a thumbs up if you enjoyed it, and subscribe for part 2 coming soon.